Hey everyone, welcome to Homeschooling channel. Today we are going to start part 5 of average chapter, that is standard deviation. In part 1 and 2 we have already covered low, medium and high difficulty level average problem. In part 3 we have covered mean, median, mode, frequency table problem, scatter plot and box and whisker plot problems. In part 4 we have covered margin of error and confidence interval. And in this video, part 5, we are going to start with basics of standard deviation. Then we will take 10 previous year standard deviation question, and at the end I'll give you 4 practice questions which you can solve by yourself and write down the answer in the comment section below. If you are thinking seriously to prepare for SAT examination, you can check out our various courses on homeschooling app and website for SAT exam at a very affordable price. All the links are provided in the description below. Now let's move on to the basics of standard deviation. In SAT examination, for standard deviation chapter, we don't have to find the value of standard deviation, or we don't need to use the formula of standard deviation. In a city examination, we just need to find the approximate estimation of standard deviation. And we have to compare the two graphs or three graphs, and we have to tell which graph is having a higher standard deviation and which graph is having a lower standard deviation. So now what is standard deviation? So standard deviation is a measure how numbers are distributed or spread out around the mean. Let's start with a very basic example of standard deviation. So as we can see, we are having 6 people here. So if we have to find the average height, average or mean height, so what we're gonna do here is we will add the height of all the people divided by number of people, that is 6. So let's say we get a mean height of 155 centimeter. So as the definition say measure of how numbers are distributed or spread around the mean. So we have 155 centimeter as the mean or average. Mean and average is same thing. And we have to see how the people of 6 people height are distributed around this mean height, that is 155 centimeter. So as we can see, this person is the tallest one. So his height is 18 centimeter more than the mean height. And then this one is 8 centimeter lower than mean height, then 15, 8, 9 centimeter lower than, and this guy has 6 centimeter above the mean. So the tallest guy would have highest deviation from the mean height, or the smallest. This is the shortest guy, shortest person, and this is the tallest person. So either the tallest person or the shortest person will have maximum deviation from the average value. So as we can see here, the tallest person is having a deviation of 18 centimeter from the mean value, and this shortest person has a 15 centimeter deviation. So we can say that the tallest person is having highest standard deviation. Then we will have this person has second highest. So first, second highest, then 9 centimeter, then this is third highest standard deviation. And these two are fourth highest because both are having 8 centimeter standard deviation fourth. And this person has the smallest standard deviation. The smallest standard deviation. So this is a basic example of standard deviation value. We have a formula for standard deviation, but in SAT examination, we just need to find approximate estimation of standard deviation. And you will not get a question like this. You will get a graphical or data point graph there, and which you have to solve, and you have to tell which graph is having higher or a lower standard deviation. Now let's move on to those examples. So let's see the graph here. And as we can see, this is our mean here. So we need to see that how the graph is spread out or distributed around the mean. So as we can see, if we see this green graph here, as you can see, this is our mean here. And from mean, it is spread out from here to here. So this will be called our spread. And if we see the red graph here, so this is our mean here, and it is spread out from here to here. So the red graph has higher spread, that means it has higher standard deviation, and the green graph has lower spread, that means it has lower standard deviation. And when numbers are arranged identically around the mean, then they have equal standard deviation. Let me show you with an example here. As we can see here, both the graphs here, this is the highest value, that is the mean value. And as we can see here, we have 4 data points and 3 data points on the left side. Similarly here, we have 4 data points and 3 data points on the left side. And on the right side, we have 5 data points. And also here, we have 5 data points are on the right side. So this is where the standard deviation is equal. So always remember, whenever we are finding standard deviation in for SAT examination, we don't need to find the value. We just need to find the approximate estimation, and we have to compare the graphs that which graph is having a high or a low standard deviation. Now let's start with these two examples. As we can see here, at 2 it is having 7 data points, and at 1 it is having 1 data point, and at 3 it is having 1 data point. So we can see this graph like this, that is going to be like this green graph. So whenever we have to find the spread, we don't need to focus on the values. We just need to see the starting point and the end point. So this is our starting point, and this is our end point. So it is starting from 1 and it ends at 3. So we have 3 units here. So the spread is of 3 units. So spread is of 3 units. Similarly, in this graph, it is starting from 1 and it ends at 5. So it has a spread of 5 units. So as we can see here, if you make a graph like this, it will look like this red graph. And as it is far more spread out, and this graph here, the, it is like the green graph, it is less spread out. So less spread means, if we have less spread, that means we have low standard deviation. And if we have higher spread, then that means standard deviation is also high. So among these two graphs, this one is having higher standard deviation because it is having higher spread around the mean, that is this, and this is having lower spread around the mean value. So this is going to have lower standard deviation. Sometime the question will be given in the data points, and sometime the question would be provided in this graph form. So you need to understand the concept of standard deviation for both data points as well as the graph. So if you take this example here, as you can see, it looks like a bell curved shape graph. So this is a bell curved. It is a bell curved shape. So and as we can see, it has spread from 1 to 3, other has spread from 1 to 5, and this one has spread 1 to 7. So spread is lowest. So what is going to be standard deviation? Standard deviation is also going to be the lowest. Now let's see what kind of curve it is forming. So as we can see here, it is forming a skewed curve. So this is called as your skewed curve. It is having a higher spread. Spread is slightly higher. So standard deviation will be higher than this one. Now let's come to this graph. So it will form a graph like this. So we can see in these two graphs, we have only one top here, one top here, one top here, and this can be considered as the mean value. Here we have two tops here. So this type of graph is called double top curve. And as we can see, spread was 3 units. Here spread was from 1 to 5, that is 5 units. Here the spread is from 1 to 7, that is 7 units. So it is having highest spread. So standard deviation is also going to be highest. So what we can say here, Among these three graphs, bell curve, skewed curve, and double top curve. So this one is having lowest spread and standard deviation. This one is having higher, and this one is having highest. So graph A, B, and C. So A is smaller, standard deviation of A is smaller than B, and B standard deviation is smaller than C. So all we have to check here is spread. And whenever we are checking spread, we don't need to consider the value while checking the spread. We just need to see how many units they are far apart. We just have to see what is the starting point and what is the ending point. Now let's see this example one more time. So as I've told you, whenever you're checking, whenever you're finding spread, you see the starting point and the end point. So it starts from 1 and it ends at 5. So we have total 5 units of spread. So spread is 5 units. We're not taking the corresponding value here. Whenever we have to find the spread, we just have to see how many units the data is being plotted here. Now here we can see that starting point is 5 and end point is 9. So spread is from 5 to 9. So spread is 5 to 9, that is 5 units of spread. Now we will see how many data points are there. So at starting, it has 3 points. So it also at the starting point it has 3, then 4, then 4 here, then 8 here, then 8 here, then we have 5 here, 5 here, then 5 here, then 5 here. So as we know from the definition, we have to measure the distribution or spread out around the mean. So this is our mean, 7, the highest data point, and the spread out here on the right side is similar. We have 2 5s here, 2 5 data points here. We are also having 2 5 data points here. Similarly, on the left hand side, we have 3 and 4 data points. So here also we have 3 and 4 data points here. So from this, we can say that standard deviation of data set 1 is equal to standard deviation of data set 2, because spread of both the data set are same, that is 5 units. Now, if I have to find the mean, median, and mode, mean, median, and mode, will both the data set will have same mean, median, mode? No. Why? Let's say, let's find out the value of these data set, because in spread we don't have to consider the value, we just see the units, the starting point and the end point. Here also starting point and the end point, and how many units are there in between to find the spread, and this units are same, so standard deviation would be same. But if we have to find the mean, median, or mode, then we have to consider its corresponding value. So let's say we have 3 data points here, and all these 3 data points have corresponding value 1. So 3 into 1, that is going to be 3. Similarly, for these 4 data points, so corresponding value is 2. So 4 into 2, it is going to be 8. Similarly, it has 8 data points and corresponding value is 3. So 8 into 3, 24. Now coming to the data set 2 here, so the starting point, it has 3 data points here and corresponding value is 5. So 3 into 5, that is going to be 15. Similarly, 4 data points and the 4 data points are there and corresponding value is 6. So 6 into 4, 24. Then 7 into 8, because 8 data points are there and each data point has a value of 7. So 8 into 7, that is 56. So as we can see here, standard deviation would be same, but the mean value, because here we have lower values and here we have higher values, so mean, median, mode would be different for each other. It's not going to be same, that we have to calculate. Now there's one more example here. As we can see in these two, data set A and data set B, as we can see, we can have this is also like a double top here. This is a double top, and here also we have 2 double tops. So let's see the graph here properly. Let's see which one among them have a highest standard deviation. So first we need to check out the spread, as the starting point is starting from 10 and it is ending at 60. So total 7 units are there. Here also starting from 10 and it ends at 16. So spread is of 7 units. Similarly here, spread is of 7 units. So should we say that the standard deviation also same because the spread is same? No. Here we can see some difference here. Here at 13, we have 3 dots. Here we have only 1 dot. So we have these 2 dots here, and instead of these 2 dots at 30, at a value of 13, these 2 dots have been put at 10 and 16. So whenever you get this type of question, you need to see the outliers, that the starting point and the end point in both the graphs. So the outliers, the starting and the end point, we have to see which is having more data points here. So as we can see here in data set B, in the outliers, in the starting point and the end point, we have 2 data points here. And here we have 1 data point here. And in the graph, in set B, we have 2 data points. So in the definition we have read, it is used to find the dispersion or degree of variation of value in a data set. So whenever we get a double top graph here, as we can see, it will go somewhat like this. So we have a double top here, and similarly we have a double top here. So whenever we have a double top graph here like this, and we have a equal spread, then we have to check out for the outliers. So the outliers, the starting and the end point, which the outliers, the data set which is having more data points at the outliers will have highest standard deviation. So here we have 2, here we have 2, and here we have only 1 at the start and the end point. So this will have lower standard deviation, and this is going to have higher standard deviation. Now let's move on to the questions now. The question number 1, it says that which of the following would decrease the standard deviation of the set below. So we have a set where we have 6 data points here, and we have to find which among these 4 values would decrease the standard deviation. So as we know, there is a relation between spread and standard deviation. So when spread increases, then standard deviation also increases. When spread reduces, or the spread become concentrated, or the data points are concentrated, or spread reduce, then standard deviation also decrease. So in the question we have to find which of the value would decrease the standard deviation. So if we have to decrease the standard deviation, then spread should also decrease. So now let's put all the options one by one. So as we can see, we have a spread from between 48 to 66 initially. But if we put 23 here, so if 23 here, so it would be far before 48. So previously our spread was this, but after putting 23, our spread will further increase because previously it was from 48 to 66. Now it is from 23 to 66. So our spread will further increase. Now let's put option B here. So after 68, after a while, 93 will come. So initially we were having a spread from 48 to 68, but if we put option C here, 93, so our spread will increase further. So as spread will increase further, then the standard deviation will increase, but we have to find which option the spread will decrease. Similarly, if we put the C option, that is 155, it will come far after 93, so 155. As we can see, spread was initially from 48 to 66. Now spread has increased from 48 to 155. So spread has increased, so standard deviation will also increase. So we have to find an option. Now coming to the last option. So as we can see, 56 will come somewhere here. So as we can see, standard deviation, because the next data that we are going to put, it is between this spread only. So this will decrease our spread because we are not putting a data point before 48 or after 66. So the data point is between this 48 to 66 range. So this will decrease our spread. Hence our standard deviation will decrease. So option D will be a correct answer. Now moving to the question number 2. In question number 2, we have two data set. Data set A, it starts from 25,000 and it goes up to 126,000, and data set B, data set A, and the data set B, it starts from 22,000 and it goes up to 600,000. So let's put it on a graph here. Let's say it is our 0, it is our 100,000. We can also write it as 100K, then 200K, then 300K, then 400K, 500K, and 600K. So as let's start with data set A here. Data set A. As we can see, it is starting from 25,000. So it will start somewhere here, 25,000, and it is going up to 126,000. So 126,000. So this is our spread for data set A. For data set B, as we can see, it starts from 22,000, and it goes up to slightly above 600,000. So it is going till here. So as we can see, the spread of data set B is far more larger than data set A. So as we know, if spread of B is greater, that means standard deviation of B will be also greater than A. And you can say that spread of A is smaller, hence standard deviation of A would be less. So now let's go through the option. So option A, standard deviation of data set A is equal to, no, this is incorrect. Standard deviation of data set B is larger than, as we can see, standard deviation of B and spread of B is greater, so then A. So option B will be your correct answer. Now let's move on to the next question. In this question, we are given list A and B. Two lists are given. Which of the following is true comparing list A and list B? Let's see what is given in the option. So option A says that the mean are different and standard deviations are different. So here we have to find two things, mean and standard deviation. So let's find out the mean first. So as we have read in the previous part 1, 2, and 3, mean is what? Mean or average. Both are same thing. So mean and average is equal to sum of observation divided by number of observation. So if we sum all of them, 1 plus 3 plus 3 plus 4 plus 5 plus 6, so the sum would be what? 21 divided by number of observation. Number of observations, so 1, 2, 3, 4, 5, 6. So 6 observations are there. So 21 divided by 6, that is going to be 3.5. Now let's find the mean of B. So 2 plus 3, 6, 8, 8 and 12, 12, 16, 16, 21. So 21 is the sum of the observations. So 2 plus 3 plus 3 plus 4 plus 4 plus 5, so 21, and divided by number of observations. So we have 6 numbers here, so divided by 6, so that is going to be 3.5. So from this, we can say that mean is same. Okay, mean is same. Now we have to find the standard deviation. Now let's put it on a graph here. Let's say the graph starts from 0, 1, 2, 3, 4, 5, and 6. And let's make another graph for list. This is for list A, and this is for list B. 0, 1, 2, 3, 4, 5, and 6. So 0, 1, 2, 3, 4, 5, 6. Now let's put the data points here. So as you can see, we have one data point at 1 in list A, then one data point at list in list A at 2, then one data point at 3, then 4, 5, and 6. In list B, as we can see, there is no data point at 1. So we have one data point at 2. So one data point at 2. Now two data points at 3. So two data points at 3. Now two data points at 4. So two data points at 4, and one data points at 5. So as we can see, it has a spread from 1 to 6, and this one has a spread from 2 to 4. So we can say that this one has a lower spread comparatively to this, so this one has a higher spread. and this one has a lower spread. So if list A has a higher spread, that means it has higher standard deviation. So standard deviation, and this has a list B has lower spread, so it will have lower standard deviations. Of list A and list B, standard deviation are different, so option B will be a correct answer. Now let's move on to the question number 4. Question number 4, it says that two different data sets are displayed in the dot plot shown. Which of the following statement is true? So let's go through the option first. So in the option, this mean of data set A, so mean is given, mean of data set A1 is less than the mean of data set 2, but standard deviation of the data set are same. So in options, two things are given. So we have to find what is the standard deviation and what is mean of these two data set 1 and data set 2. So let's first find out standard deviation. So to find standard deviation, first we have to find the spread. So as we can see that uh, from where the data points are starting, at first point it has 3 data points, then it has 4 data points, then it has 8 data points, then 5 data points, then 5 data points. So it has a spread from here to here. So we have a spread from 5 to 1. So 5 units spread we have. Similarly, we can see in the data set 2 from where the data points are starting. At first it has 3 data points, then 4 like this, 3 here, so 3 was also here, 4 data points were here. So second point where the data points are starting, so second place we have 4 data points, then we have 8 here, similarly we have 8 here, then we have 5 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 here. So we can say that spread, as we can say, it is 1 2 3 4 5. So 5 points are there. So similarly we can calculate 1 2 3 4 5 5 points are there, and we can say that the spread is similar in both the sets because it's 3 4 8 5 5 3 4 8 5 5. So from this we can say that spread is equal in both data set 1 and 2. 1 is equal to spread of data 2. So from this we can say that if spread is equal, so standard deviation of data set 1 is equal to standard deviation of data set 2. So we have found what is the relationship in standard deviation. This one is important. Now we have to find what is the mean. So as we can see that corresponding value is given, as we can say, as you already know, the spread is equal here, but the corresponding value to those data points are higher in this data set, because here we have let's consider this one here. So we have the value corresponding to these 3 data points, that we have 3 data points. So and the corresponding value is 1, so its value would be 3. Here we have 4 data points and corresponding value is 2, so 4 into 2, 8 will be there. Here 8 data points are there and the corresponding value of each data point is 3, so 8 into 3, 24 will be there. But here similarly in data set 2, we have 3 data points, but we do not, but the corresponding value is, instead of 1 it is 5. So 3 into 5, that would be 15 here. Similarly for here it was 2 into 4, 4 data points were there and the value was 2, but here 4 data points are there but the corresponding value of each data point is 6, so 6 into 4, 24. Similarly 7 into 8. So as we can see here the numbers are higher, so if we add all of them and we will find the mean, so mean of B will be greater than mean of A, because here the sum of the observations, because here it was 3 8 24, here the sum of the numbers are 15 24 7 8 7 56. So the numbers are higher in data set 2 as compared to data set 1. So the mean of data set 2 will be greater than data set 1 mean. So now let's find out the option here. So first we have to find the option where mean standard deviation is same. So standard deviation is same, and option A, it says that the mean of data set 1 is less than mean of data set 2. So that is also true. So option A will be your correct answer. Now let's move on to the to question number 5. Question number 5, it says that the 22 students in a health class conducted an experiment in which they recorded their pulse rate in beats per minute before and after completing a light exercise routine. The dots plot below showed the result. S1 and S2. S1 and S2 are standard deviation. So S1 is standard deviation and R1 is range of the data before exercise. So S1 is standard deviation and R1 uh, is the range of the data for beats per minute before exercise. And S2 and R2 are standard deviation and range of data after exercise. So S2 and R2 for the data after exercise. So we have to find which of the following is true. So what we have to do here is, because we have to find two things, that is range. This is for before, and for after we have to find range and we have to find standard deviation. So as we know, range is equal to maximum value minus minimum value. So that is going to be 88 minus 56 in before graph. So that is equal to 32. Similarly, uh, for this dot plot after exercise, as we can see, so range is maximum minus minimum. So maximum is 112 and minimum is 80. So 112 minus 80, that is equal to 32. So we can say that range is same. So R1 is equal to R2. So we can cancel this option and this option. So we'll have either the option A or option C. Now we have to find the standard deviation here. As we can see that it looks like a bell curve. And as we have read in the basics, bell curve has spread has a lower spread and lower standard deviation. And here, as we can see a peak here, then it goes down, then one more peak here. So this is a double top. So here spread is larger, and so the standard deviation is higher. So we can say that option A says that, as we already know, R1 is equal to R2. Range of both the dot plots are same, but here the standard deviation. So standard deviation of after, so standard deviation here in after exercise plot is higher, and in this standard deviation is lower. So we can say that S1 standard deviation 1 is not equal to standard deviation of other graph after and before exercise. The standard deviation is not equal because standard deviation after exercise is higher than before exercise. So option C is your correct answer. Question number 6, it says that the table below gives the distribution of high temperature in degree Fahrenheit for city A and city B over the same 21 days in March. Which of the following is true about the data shown for 21 days? So let's go through the option here. In the option, standard deviation of the temperature in city A is larger. So we have, so standard deviation is given in all the options. So we have to find the standard deviation of city A temperature and city B temperature. So as we can see, we have temperature ranging from 76 to 80, and same here, 76 to 80 degree Fahrenheit, and it has different frequency. So we'll put a graph here. So 76, 77, 78, 79, and 80. So 76, 77, 78, 79, 80. Similarly, 77, 78, 79, sorry, 76, 77, 78, 79, and 80. So in city A, this is for city A, and this is for city B. City B, At 76-degree Fahrenheit, we have frequency 1, so we'll put one data point here. Similarly, for 77, we have one data point here. For 78, we have two data points. For 79, we have 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So we have 14 data points, and for 80-degree Fahrenheit, we have 3 data points. Now, as we can see here, we are getting a bell curve here. It is a bell curved. Now let's start with 76. So for 76, we have a frequency of 6, so we'll put 6 data points here. 1, 2, 3, 4, 5, 6. 77, we have 4. 1, 2, 3, 4. 78, we have 2 for city B. 79, we have 3. 1, 2, 3. And for 80, we have 6. So 1, 2, 3, 4, 5, 6. So as you can see, so it's a double top and it's a bell curve, slightly skewed on the left hand side. So as we have read in the basics, bell curved graph has a lower spread, hence their standard deviation would be less. And double top curve, we have higher spread, so hence standard deviation is high. So we can say that option C, the standard deviation of temperature in city B is larger than city A. So option C is your correct answer. Now let's move on to question number 7. Question number 7, it says that two independent survey asked random sample of 500 people about the distance they commute to work each day. The result of the surveys are detailed in the table below. Which statement is true? So we have to find which of the following statement is true. Let's go through the option. So there is a greater variation in distribution of the distance people commute to work in survey. So variation, we can also call it as spread or standard deviation. So we have to find among these two survey which is having a higher variation or a spread or the standard deviation. So what we're going to do here is let's make a graph of first survey A. As survey A, the mean value is what? Mean value is 13.9. 13.9. So this is your mean value. And it has a standard deviation of 1.5. So 13.9 plus 1.5, it is going to be 1.5. So 15.4. And we have taken plus 1.5 standard deviation, and on the left side, we'll take minus 1.5 standard deviation. So 13.9 minus 1.5, that is the standard deviation. So what it is going to be? So that is 12.4. So we will have a mean here. So we will have a curve like this. So as we can see here, mean is at 13.9 and our standard deviation is 1.5. So we will take a value, we will plus a 1.5, that is 15.4, and we will reduce 1.5, that standard deviation, that is minus 1.5, and then our value will be 12.4. And as you can see, spread from here to here is 3. 15.4 to 12 minus 12.4, the spread is 3. Now we'll do the same thing for survey B. The mean is where? The mean is at 15.1. So mean is here, so 15.1, and it is also having a standard deviation of 1.5 miles. So 15.1 plus 1.5, it is going to be 16.6, and 15.1 minus 1.5, it is going to be 13.6. So we will get a similar graph like this. As we can see, the spread is from 13.6 to 16.6. So 16.6 minus 13.6. So we have same spread. So spread is same is equal, spread in survey A is equal to spread in survey 2. So we can say that standard deviation of survey A is equal to standard deviation of survey B. So let's find out the options. Option C, the variation in the distribution of the distance people commute is same. So distribution can be also represented with spread or standard deviation. So option C is your correct answer. Now, question number 8. In question number 8, it says that the weight in pounds for 15 horses in a stable were reported, and the mean, median, range, and standard deviation for the data were found. Horse with the lowest reported weight was found that it was actually weighed less 10 pound less. So the 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 horse with the lowest uh, weight was weighted 10 pound less. So which value remains unchanged? So among these values, standard deviation, mean, median, and range, which value remain unchanged if four of the values are reported using the correct weight? So we don't know what are the weight of these 15 horses. Let's say it starts 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have total 50. Let's say the weight of the lowest weight horse is 100 pound and highest is 150. But in the question, it is given that the horse with the lowest reported weight was found that to be actually weighed 10 pound less than the reported weight. So in reality, it was reported at 100, but in reality, the lowest weight horse was only 90 pounds. So instead of 100, we will have 90. So let's find out the effect. So here, initially, we are taking the horses were from 100 pounds to 150 pounds, but in the question, it said that it was reported 10 pound less. So from 100, it is going towards 90. So previously, the spread was from 100 to 150, but now, as the weight was reported 10 pounds less, so now the spread has increased. So it is from previously it was from 100 to 150, but now spread has increased from 90 to 150. So previously spread was from 100 to 150, and now spread has increased. So as spread has increased, so standard deviation will also increase. So standard deviation will change. So it is going to be changed. So this option will be incorrect. Now coming to the mean. So as we can see, the lowest weight horse, their weight has been further reduced to 90 pounds. So mean will also reduce. Hence, it will change because mean is sum of all the horses, weight of all the horses divided by number of horses, that is 15. So one of the weight that was 100, now it has been reduced to 90. So when we will find the mean or the average of all the 15 mean or average weight of all the 15 horses, then the mean will decrease slightly. Hence, there is a change in mean. Now let's come to the median. Now median means the middle number. So as we know that only this first number is changing from 100 to 90, and median, we have 15 numbers, so eighth number will come as median. So 1, 2, 3, 4, 5, 6, 7, 8. So this is your eighth number horse. So whatever the weight was previously when it was 100 pounds, it will remain same when it will reduce 10 pound less. So median will remain same, median will be same, hence unchanged. So option C is your correct answer. Now let's also find out for the range. So previously, range was the highest weight of the horse was 150 and the lowest was 100. So this is 50. But after wrong reporting, the lowest weight horse was 90. So what's gonna change here? So its range is going to become 6. So range is also changing. So range will not be your correct answer. So only median will remain unchanged in this case. So option C is your correct answer, median. Now, question number 9. The maximum value of data set consisting of 25 positive integer is 84. Let me put a data set 1. It has 25 positive integer. And the question, it is given that the maximum value of data set consisting of 25 positive integer is 84. So maximum value is equal to 84. A new data set, let's consider it as a data set 2 consisting of 26 positive integers. So it has 26 positive integers. 26. is created by including 96 96 in the original data set. So previously uh, we have 25 values, and in which 84 was the highest. Now in another data set, one more number is added, that is 96. So here in 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 this set we have added one more number, that is 96. So we will have all the numbers that is in the data set 1 plus 96. So previously it was 84 was the highest number, but we have added 96. So here the maximum value would be 96. We don't know what is going to be the minimum value. So minimum value, let's keep it as x. And because we have added 96 in the data set 1, so whatever the minimum value would be in the data set 1 will be also the minimum value in data set 2. So we have taken x as the minimum value in data set 1. So in data set 2 we'll have the minimum value as x. So we have in data set 1 we have 25 numbers, in which 84 with x as the smallest value, and 84 was the maximum value. But these 25 integers we have added 96. So now we will have the minimum value same what was in the data set 1, but here 96 was added. So now 96 is greater than 84, so the maximum value would be 96. So now let's find the range of data set 1. So range, let's say it R1 for data set 1. So 84 minus x, and let's find the range for data set 2, R2. So it is going to be 96 minus x. So we have to find in the question that which of the following measure must be 12 greater for the new data set. So we have to find among these range, standard deviation, median, mode, which of the value among these four will be 12 greater for data set 2, or the new original data set. That is original new data set than original data set. So this one is your new, and this was your original data set. So if we subtract the range R2 minus R1, so 96 minus x, and R1 is 84 minus x, so minus 84 minus x. So this is going to be 96 minus 84 minus x, and minus minus plus x. X and x get cancelled. So R1 minus R2 is 12. So we can say that as the question has asked, which of the following measure must be 12 greater for the new data set, that is data set. So range, if you find that if you find the range and range of data set 1 and data set 2, and if you find its difference, then it will come 12. Hence option A is your correct answer. Now question number 10, it says that the figure, it's not above, it's below. The figure below shows a standard normal distribution with mean of 160. So this is our mean, and standard deviation D, including approx percentage of distribution corresponding to the region shows. So we have distribution, percentile distribution, 2%, 14%, 34, 34, 14, and 2%. So if the value 148, so here this is our mean value. So this is our mean value. So if value 148 is 12th percentile, so 160 is the mean. So we will get value 148 on the left hand side. So we will get 148 somewhere here. Because 148 is less than 160, so we'll get a value. But in question, it is one more thing is mentioned, that if the value of 148 is 12th percentile, so from starting it is going to be 12th percentile. So 12th can be written as 2 plus 10%. 2 plus 10% is equal to 12th percentile. So we already have 2 here, but 140 is a 12th percentile, so it will come somewhere in this region. And for these region, it starts from here and it ends here. And we have a standard deviation from the starting point as 160 minus 2d. And here we have uh, 160 minus d. So we have to find which of the following is the best estimate of the standard deviation of the distribution. So what we're going to do here is our 148th value will lie in this range of standard deviation, in this range of 160 minus 2d to 160 minus d. So what we're going to do here is we have to find the value of standard deviation. So what we're going to do here is 60 minus 2d and 160 minus d. So what we're going to do here is d is 5 here. So let's put it here. So 160 minus 2 into 5, that is 2 into 5, that is 10, that is equal to 150. Now 160 minus d, so 160 minus 5, as standard deviation in the option A is given. So 160 minus 5, so that is equal to 155. So we have a range of 150 to 155, but here the value is 148. So it is not in the range. So option A is not correct. Now let's take D is equal to 10. So 160, and this we'll put in this equation, 160 minus 2D. So 2 into 10, that is D is 10. So 20, that is going to be 140. And for this 160 minus D, so 160 and D is 10. So that is equal to 150. So as we can see, the value 148 is coming in this range 140 to 150. So here it is, you can write it if the correct standard deviation value would be 10. So this option B is a correct answer. Now, these are 4 practice questions on the topic which I've taught you recently. Do solve these questions to test yourself and write down the answer in the comment section below. Students who will answer all the questions correctly, their answers will get pinned in the comment section by me. Now, the first question, as you can see, it uses the same concept as the first example I have shown you, where 155 centimeter average height was given, and the tallest and the shortest person has the highest effect on the standard deviation. So this question works on the similar concept. Now in question number 2, I'll give you one more small hint in this question, as it is given 2.95 and a standard deviation of zero point 0.1 of 12 cents. So 12 cents plus 12 cents, and here minus 12 cents. Which of the following price is not within 2 standard deviations? So 2 standard deviation are there. So this was our mean value 2.95. So we will add 12 cents 2 times. So one more time. So plus 12 here minus, and on the left side minus 12 cents, and one more time minus 12 cents. So this is going to be our range, and we have to find which of the following prices not within the range. Now, if you like the way I teach and want to buy a comprehensive course for SAT exam starting at a very affordable price, you can check out our homeschooling app and website. All the links are provided in the description below. One more thing, don't forget to like, share, and subscribe to this channel so you can get updates of upcoming free video that I'm going to upload on YouTube in future. Thank you very much, and may God bless you.